Hello everyone, welcome to All Chemistry. In today's video, I will talk about 10 most important trends in S block elements, means in alkali, alkaline metals and group 1 2. 10 most important trends. So I will discuss about them, what will be the trends and their explanation. Let's get started. So in our very first question, we have comparison of sizes of N3 minus, sodium plus, F minus, O2 minus and magnesium 2 plus. And as I have told you, we will discuss about group 1 2 element. But our first question is a very basic radius question. That's why I have kept that question. So here, whenever we have such type of question, we know that anion having more charge will have the highest size, and then we have to consider the periodic trend also, means from right to left the size of the atom increases, so that thing also. Okay, so our very first question is increasing order of ionic size. So we have here N3 minus, sodium plus, F minus, O2 minus and Mg2 plus. Now you look, whenever we are going for ionic size, so ionic size means size of that ion, and size of that ions depends on charges and on the atomic number also. Now, so mutually we will take actually Z and E ratio. So in Z and E ratio, here total number of that electron we can see for nitrogen total number of electron will be 10, for sodium plus 10, for fluoride minus 10, for oxide 10, magnesium 2 plus 10. So here Z by E ratio will completely depends upon N, completely depends upon Z. So higher the Z means higher the negative charge, higher will be the that radius means size. So here size trend will be in the increasing order. So first we will write sodium plus, then there will be magnesium 2 plus, then there will be F minus, then O2 minus, and at the end N3 minus. So for the basic concept, I have kept this means. So in the next there is decreasing thermal stability of group 2 metal ion sulfate, and here we have barium sulfate BeSO4, magnesium sulfate MgSO4, calcium sulfate CaSO4, and strontium sulfate SrSO4. Now the thing is, when we are considering this, we will take here the cation is beryllium 2 plus and anion is SO4 2 minus. Here magnesium 2 plus and SO4 2 minus, calcium 2 plus and SO4 2 minus, and here strontium 2 plus and SO4 2 minus. So for thermal stability, as we know, sulfate ion is a large anion. So for this large anion, the thing will be like SO4 2 minus like this. So if it binds with larger cation, so that binding will be more prominent, and that's why with increasing the size of the cation, the interaction between anion and cation will be good, means the bonding stability will be better. That's why the stability trend will be like barium sulfate, magnesium sulfate, calcium sulfate, strontium sulfate. So this one is the increasing stability. As in the question this is asked to write the decreasing stability, so our answer will be strontium sulfate first, then calcium sulfate, then magnesium sulfate, and at the end, barium sulfate. Moving towards the third question. The third question was arrange them in increasing order of their metallic character. So our elements are boron, aluminium, magnesium, potassium. Now to arrange them in increasing metallic character, we have to know what does that metallic character. Metallic character means any element that having tendency to lose its electron and to form positive charge will be called metal. That means which elements have the higher tendency to form positive charge be more metallic in nature. So as here you can see here the elements are boron, aluminium, magnesium, potassium. Boron is from group 13, aluminium is from group 14. So our group 1 2 element is potassium group 1, magnesium group 2. So here, the more we go from right side to left side, size of the atom increases and more tendency to give electron increases. That's why metallic character will be higher for potassium and magnesium metallic character will be higher than boron, and boron having more than aluminium. That another thing which acts means in between boron and aluminium is in the third period, whereas boron is in the second period. Now, if we go up to down, then also metallic character increases. That's why here most metallic will be nature, potassium, then magnesium, then aluminium, and at the end boron. So that will be the trend in the increasing order of metallic character. Now for the fourth question, there is increasing order of carbonate stability of group 2 elements. So we have barium carbonate, we have magnesium carbonate, we have calcium carbonate and strontium carbonate. Now again for carbonate, so if we see carbonate as an anion, so carbonate is a large anion. So here the cations are changed. So here beryllium 2 plus, magnesium 2 plus, calcium 2 plus and strontium 2 plus we have. So here in all that cation, when cation is attaching with larger anion, so that interaction will be better. That's why carbonate stability will be in this trend. When we will go from beryllium towards strontium, the carbonate stability will increase. So this will be the trend. Now I am moving towards the fifth question. So our fifth question is basic character of hydride. So what we have group 1 hydroxide, lithium hydroxide, sodium hydroxide, potassium hydroxide and rubidium hydroxide. So if we want to see the basic character, so basic character means the tendency of that particular hydroxide to donate hydroxide ion, HO minus ion. So more the tendency to donate hydroxide ion, more will be the basicity. Now if we go up to down, we know the size of the element increases. So because of increase of size, the element have more tendency to donate its electron and have more tendency to form lithium plus, sodium plus, potassium plus and rubidium plus. That's why with more tendency of forming for cation, there is a more tendency of forming hydroxide ion also. So that's why basicity or basic strength will be in the order from left to right. The increasing basic strength will be lithium hydroxide, sodium hydroxide, potassium hydroxide and rubidium hydroxide. Now moving towards our sixth question. Okay, our sixth question is radii of hydrated cation of group 1, lithium, sodium, potassium and rubidium. Now, whenever we're considering only the cation size, the cation size order will be in this order. But they want the trend of hydrated ion, hydrated cation size. So, the smaller will be the cation, more will be this one, means water molecule will surround it more. So smaller one is lithium positive, so more water molecule will be there around lithium positive. So hydrated ions size will be more for smaller cation. Because larger the cation, less water molecule will be there. So because of the smaller size, more water molecule will be there. So hydrated cation trend will be highest for lithium positive and lowest for rubidium positive. Now moving towards seventh question. So our seventh question is, here it is asked to arrange them in the electronegativity trend. So this one is the most easiest question. Means if we are trying to arrange them in more electronegativity trend, as we know, if we go from up to down in a periodic table, so electronegativity decreases. So lithium in the uppermost position, cesium in the lowermost. So electronegativity trend will be lower from high from up to down from lithium to cesium, electronegativity trend will decreases. Now moving towards question number 8. Now in question number 8, it is asked to arrange them in the solubility order. The hydroxide of group 2 ion in solubility order: barium hydroxide, calcium hydroxide, and strontium hydroxide. So if we are taking these and we are seeing the solubility order, so always remember, more it can give cation and anion in water or in any solvent, the more solubility will it face. So as we know, if we go from up to down, electropositivity character increases. So that's why more giving tendency of more cation and anion will increases from beryllium to strontium. So that's why solubility trend will be here like this way: beryllium hydroxide, calcium hydroxide, then strontium hydroxide. Then our ninth question: arrange the following in their increasing order of ionic character. We have some hydrides of group 2 metal ion. So beryllium hydride, magnesium hydride, and calcium hydride. So as you can see, hydride is of small anion. So it will go more with the large, means the larger the cation, larger will be the covalency tendency. But here the thing is, more it can give the cations, so more it will be ionic in character. So that's why if we go from up to down, the cation giving tendency is higher, so ionic character will be higher from up to down. Basically, beryllium and magnesium is not ionic in character, they are covalent in character, and more we down to the group, more will be ionic in character. Now we will move towards the 10th and the last question. So our last question is reactivity order for lithium, sodium, potassium, cesium. Now see, all of them are metals. They are in the utmost left position of periodic table, and they are having a lower ionization energy than other element. So they will more means lose electrons and they will form positive ion. So more they will form positive ion, that means they will face more reactivity. They have a more tendency to react with other elements. So here the reactivity tendency will increases as we go down the group, because of with increasing size the electron will be in a more distance from nucleus, so more less attraction towards nucleus. So with increasing size, tendency of giving electron increases. That's why also reactivity order increases from up to down. If this video was helpful to you, please like and give comment what type of video you want. So I have here added few more trends, group 1 and group 2, and how this video was, and give comments, and thank you very much for watching.